In 1982, a team of Turkish sponge divers working the seafloor off the southwestern coast of Turkey snagged their equipment on something that should not have been there. It was not rock, it was not coral, it was metal, shaped metal, stacked in rows on the bottom of the Mediterranean Sea, at a depth of around 150 feet, covered in 3,000 years of sediment, sitting exactly where it had fallen sometime around 1300 BCE. What they had found would become the most significant Bronze Age shipwreck ever recovered, and buried inside its cargo, in the specific chemistry of the metal it was carrying, was a question that points directly across the Atlantic Ocean to the Great Lakes of North America. The official explanation for where that metal came from has never been fully satisfying. The numbers have never quite worked. And the harder researchers have looked at the evidence, the more uncomfortable the standard answer has become. This is the story of a shipwreck, a cargo, and a mystery that connects the ancient Mediterranean to the forests of Michigan, in ways that the accepted timeline of human civilization was not built to accommodate. The wreck is known as Uluburun, named after the cape off which it was discovered on the Turkish coast near the modern town of Kos. Archaeological excavation began in 1984 and continued for 11 seasons. What the excavation team recovered was extraordinary by any standard. The ship itself, a vessel approximately 15 meters long, built from cedar, had been carrying one of the most diverse and valuable cargo loads ever documented from the ancient world: Egyptian gold jewelry, Canaanite storage jars, Cypriot pottery, tin ingots, glass ingots of cobalt blue, an Egyptian royal seal, ebony logs from Africa, hippopotamus ivory, ostrich eggs, a scarab bearing the name of the Egyptian queen Nefertiti. The ship was a floating inventory of the Bronze Age world, a vessel moving between civilizations, carrying the materials that kept the economies of Egypt, Canaan, Cyprus, and the Aegean running. And at the bottom of the cargo hold, forming the heaviest and most substantial part of the load, were the copper ingots, 354 of them, each one cast in the distinctive oxhide shape, a flat rectangle with 4 protruding corners, resembling a stretched animal hide, that was the standardized shipping form for bulk copper in the Bronze Age Mediterranean. Together they weighed approximately 10 tons of copper on a single vessel, moving through the eastern Mediterranean sometime around 1300 BCE. When the excavation team catalogued the ingots and began the process of determining where the copper had come from, they expected the analysis to be straightforward. The Bronze Age Mediterranean had known copper sources. Cyprus was the most significant, so significant that the Greek word for copper, kypros, came directly from the island's name. There were also deposits in Sardinia, in the Sinai Peninsula, in the Aegean region. The copper from Uluburun, researchers assumed, would match one of these sources cleanly. It did not. The technique used to identify the origin of ancient metals is called lead isotope analysis. Different geological copper deposits formed under different conditions over millions of years, and those conditions produced distinct ratios of lead isotopes, specific variants of the element lead, that are locked into the copper at the moment of its formation. Smelting and alloying change the form of the metal, but they do not alter the isotopic ratios. The signature survives. It is, in effect, a geological fingerprint that the copper carries permanently regardless of what happens to it afterward. When researchers applied this technique to the Uluburun copper ingots, the results were not what they expected. Some of the ingots matched known Mediterranean sources reasonably well, but a significant portion of the cargo, a measurable, reproducible portion across multiple independent analyses, returned isotopic profiles that did not match Cyprus, did not match Sardinia, did not match the Sinai, did not match any known copper source in the Old World, with the confidence that a clear attribution requires. The results were published. They were noted. They were contested by researchers who preferred alternative interpretations. And then, in the way that uncomfortable data tends to be handled, they were absorbed into the literature and discussed in footnotes rather than confronted directly. But the question they raised did not go away, because there is a copper deposit whose isotopic signature has been proposed as a match for the unattributed Uluburun material. It is not in the Mediterranean, it is not in Europe, it is not in Africa or the Middle East, it is in the Upper Peninsula of Michigan. I want to be careful here about the difference between what the isotopic data shows and what it proves. These are not the same thing. What the data shows is that a portion of the copper aboard the Uluburun wreck carries a chemical signature that does not match the known Old World sources with confidence, and that the isotopic profile of Lake Superior native copper falls within a range that is consistent with some of those unattributed samples. Consistent with is not the same as definitively from. The methodology has limitations. The database of known copper sources is not complete. Alternative Old World sources that have not yet been characterized may exist. What the data does not do is go away. Multiple independent research teams, working with different samples from the Uluburun cargo and from comparable Bronze Age sites across the Mediterranean, have produced results that consistently resist clean attribution to the known European and Mediterranean sources. The problem is real. The gap in the explanation is real. And the Lake Superior deposit is one of the few sources on Earth with both the scale and the isotopic profile that could plausibly fill that gap. The question is whether a civilization capable of crossing the Atlantic and extracting copper from the Great Lakes could have existed at the right time to supply the Bronze Age. And the physical evidence from Lake Superior itself says yes. The ancient mine workings of the Upper Peninsula, Isle Royale, and the broader Lake Superior region were first documented by American surveyors and geologists in the 1840s, when mining companies moving into the Upper Peninsula found something they had not anticipated. The copper deposits they had come to exploit had already been extensively worked. Ancient pits, some of them 60 feet deep, drainage systems cut into the walls, wooden shaft supports partially preserved in waterlogged ground, stone mauls, heavy, shaped granite tools clearly designed for driving and braking, left at the work sites in quantities that implied a substantial and sustained labor force. Federal geologist Charles Whittlesey surveyed these workings systematically and published his findings in 1863. His estimate for the total copper extracted from the Lake Superior region by the ancient miners fell between 1.5 billion and 2 billion pounds. Radiocarbon dating of wood recovered from the ancient shaft supports conducted in the 20th century produced dates ranging from 3,000 to 5,500 years before the present. The most intensive period of extraction appears to fall between roughly 4,000 BCE and 1 Viso BCE, a window that overlaps precisely with the period of peak Bronze Age copper demand in the Old World. The Uluburun ship went down around 1300 BCE. The Lake Superior mines were operating at or near their peak intensity at exactly that moment. The Uluburun wreck is not the only place this question appears. The broader Bronze Age copper problem. The documented gap between the copper demand of the period and the known supply capacity of the Old World sources has been a quiet but persistent issue in archaeometallurgy for decades. Researchers studying the aggregate copper consumption of the European and Mediterranean Bronze Age have consistently found that the numbers do not close. The known deposits of Cyprus, Sardinia, the Alps, and the Aegean region, even at maximum estimated production, fall short of what the archaeological record of Bronze Age copper use implies was actually circulating. This gap has produced competing explanations. Some researchers propose that there are significant Old World copper sources that have not yet been identified or fully characterized. Others argue that the production estimates for known sources are too conservative. These are legitimate scientific positions and they may be correct, but neither of them has closed the gap. The shortfall remains documented. And the Lake Superior deposit, the largest known deposit of native copper on Earth, with extraction evidence spanning the exact centuries when the Bronze Age was most copper-hungry, remains the only known source of sufficient scale and appropriate isotopic profile to fill it. The question is not whether someone could have been moving copper across the Atlantic in the Bronze Age. The question is whether the evidence we have is sufficient to say they were. Here is where the Uluburun evidence connects to something I covered in a previous investigation. In 1894, a documentation effort connected to the Wisconsin State Historical Society recorded testimony from Ojibwe elders describing a people who had worked the Lake Superior copper deposits before the Ojibwe themselves had established dominance in the region. The accounts described organized extraction on a large scale, multiple groups working in coordination. Copper moved systematically to the shoreline and loaded onto vessels. The people described arrived from the east, from across the Great Water. They came for the copper, and at some point they stopped coming. The elders described the use of fire in the mining operations. Fire against the rock face, then cold water applied to the heated stone. This is fire setting, a specific and sophisticated mining technique that appears independently in the ancient copper mines of the Sinai, the silver mines of Greece, and the gold mines of Egypt. It is not intuitive. It is not discovered by accident. It is developed through generations of practice in a tradition of underground mining. The physical evidence from the Lake Superior mine shafts confirms fire setting was used there. Fire-cracked rock, ash deposits, thermal fracture patterns in the walls. The oral testimony and the physical archaeology arrived at the same technical conclusion from opposite directions. Now hold that picture against the Uluburun cargo, a Bronze Age vessel carrying 10 tons of copper with an isotopic signature that does not clearly match any known Old World source. Operating in the same century that the Lake Superior mines were at peak production, moving through a Mediterranean trade network that included civilizations. The Phoenicians, the Mycenaean Greeks, the Egyptians, with documented maritime capability and documented interest in controlling copper supply routes. The Phoenicians, the most sophisticated maritime traders of the first millennium BCE, were documented in ancient sources as instructing their captains to protect trade routes by any means necessary, including deliberate misdirection. References survive to Phoenician voyages westward beyond the Pillars of Hercules into the open Atlantic. What they were trading for in those western routes the surviving records do not specify. The records were not intended to specify. That was the point. There is a detail about the Uluburun copper ingots that tends to get overlooked in general accounts of the wreck, and it matters for understanding what the cargo actually represents. The oxhide ingot shape, the standardized flat rectangle with 4 protruding corners, was not unique to Uluburun. It appears across the Bronze Age Mediterranean in hundreds of examples, from Sardinia to Cyprus to the Aegean. The shape is so consistent and so widespread that researchers have concluded it represented a standardized unit of trade, a recognized form that allowed merchants from different cultures, speaking different languages, to exchange copper without ambiguity about quantity or quality. Standardization at that level implies something specific about the trade network that produced it. It implies repeated, regular, organized exchange between parties who had established enough of a relationship to agree on a common form. It implies, in other words, a mature trade system. Not occasional contact, but sustained commercial relationship over time. If Lake Superior copper was entering the Bronze Age Mediterranean trade network, it would not have done so as irregular lumps of raw material. It would have entered in the standardized form that the network used. It would have been cast into oxhide ingots somewhere, either at the source or at an intermediate processing point, and then moved through the existing commercial channels. This means the absence of obvious Lake Superior artifacts in the Mediterranean record is not itself evidence against the connection. If the copper was processed into the standard form before entering the trade network, it would be archaeologically indistinguishable from locally sourced copper until the isotopic analysis was applied. And the isotopic analysis, when applied, is producing the uncomfortable results that the field has been sitting with for decades. I want to come back to the wreck itself, because there is something about its physical situation that has stayed with me. The Uluburun ship went down in deep water off a cape on the Turkish coast. The best reconstruction of its final hours suggests it was caught by a storm, perhaps a sudden squall of the kind that the eastern Mediterranean generates without warning while sailing close to the coast. The copper ingots, stacked in the hold in rows, would have shifted as the ship lost stability. 354 ingots, each weighing approximately 25 kilograms, shifting in a hull that was already taking on water. The ship would have gone down quickly, and then it sat on the seafloor for 3,000 years, undisturbed, covered slowly by sediment, waiting for a sponge diver's equipment to snag on a corner of a copper ingot in 1982. The cargo that survived, that 3,000-year wait, is one of the most complete windows we have into the Bronze Age commercial world. And the question written into the chemistry of those ingots, where did this copper actually come from, is one of the most significant open questions in the archaeology of the ancient world. The lake was quiet, as the Ojibwe remembered it. The sea, it turns out, was not as forgetful. What the Uluburun wreck does, when you hold it against everything else, the Lake Superior mine sites, the radiocarbon dates, the extraction volumes, the Ojibwe oral testimony, the Bronze Age copper shortfall, is give the larger picture a specific physical anchor. This is not a theory about abstract civilizational connections. This is a specific ship, carrying a specific cargo, at a specific moment in history, whose chemistry points toward a specific place that the conventional historical framework says should have had no connection to the Bronze Age Mediterranean. The methodology that produced that result is not fringe. Lead isotope analysis is standard archaeometallurgical practice. The researchers who produced the uncomfortable results were not alternative historians. They were working scientists publishing in peer-reviewed contexts, and the results they produced have been reproduced across independent studies using different samples from different sites. The gap in the explanation is real. The Lake Superior deposit is real. The overlap in timing is real. The Ojibwe testimony describing exactly the kind of organized maritime extraction operation that would be required to supply a Bronze Age trade network is documented and real. We do not know, with the certainty that the historical record would require, that Lake Superior copper was aboard the Uluburun wreck. What we know is that the copper aboard that wreck came from somewhere that has not been satisfactorily identified, that Lake Superior is the only known source of sufficient scale and appropriate isotopic profile to explain the gap, and that the physical evidence from the Lake Superior mine sites describes an operation of exactly the kind and exactly the period that would be required. The ship is on the seafloor off the Turkish coast. The mines are still in the ground in Michigan. The isotopic signature connects them imperfectly but persistently. Across 3,000 years and 4,000 miles, that is not a conclusion, it is a question, but it is a question with more physical evidence behind it than most of the answers that have been offered so far. If this investigation opened something for you, share it with one person who needs to see it.